Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at something that will allow you to replace a hard drive like this with an emulator. And this is an MFM hard drive with an ST-506 interface. They're very old, they're hard to find ones that work. This one does work, and they're very noisy. So if you have a machine that requires you to use a hard drive like this, and not just this particular model, but any that uses this interface, the thing we're going to look at today will allow you to replace that drive and get to something a little bit more modern and a little bit more reliable. So without further ado, let's get right to it. All right, I have a package here from Stuart. Yes, it's the same Stuart that has sent in a bunch of cool, interesting things to the channel. I think he warned me not to use a knife, and I just used a knife. So I'm gonna be very careful. Hopefully I didn't ruin whatever's in here. Just carefully cut the tape. I think it'll be fine. Yeah, I didn't cut through the top here. We have a note. Packing material. All right, well, let's see what the note says first. Hey, Adrian, after watching your 5170 videos, I thought this might help out since people were giving you a hard time about not using all original equipment. And yes, if you watch my 5170 series, it was Stuart who did all the BIOS hacking necessary to modify the original Type 3 IBM BIOS to bypass overclocking, to bypass all those other errors and restrictions that IBM had put in place. He goes on to say, while you may still not get all the way to being 100% pure, this may help test and preserve some equipment. Now on to the important stuff, no more candy reviews. And yeah, that's right. Lots of viewers have sent in candy and I really do appreciate it. But I made my first candy review video, I put it up on the second channel, and it was a disaster. Specifically, it got barely any views. It was by far the worst video I have ever put out. So I think that kind of says I won't be doing any more bespoke candy reviews, and I'm gonna try to kind of get them in here and there maybe, but honestly, to everyone who has sent stuff in, I really appreciate it. There was a huge assortment of stuff that was just candy, so there wasn't even a piece of retro equipment to show as well. And I'm not really sure how to fit those in on videos because of the fact that, well, like I said, a total disaster. Anyhow, Stuart goes on to say, since you're off the candy reviews, I thought I would send you something else you can try on camera. Hopefully we can start a new segment for you. Keep up the good work, Stuart. All right, so let's see. What is in this box exactly? Well, we have something electronic. And then there's a little bag here from Amazon, and this is probably what he was talking about to not cut into with a knife. What is this exactly? Zebra tarantula. Okay, so is this like a freeze-dried spider? Because I am, let me grab a cutting mat here, cut this open. Well, oh boy. Okay, yeah. I don't know what to say. I understand that insects and arachnids like this are probably going to be part of our food supply in the future in order to feed the world's population, like bugs and insects and things. It's a good source of protein. I just am not so sure about eating them like this. Maybe I could get used to it, but at this point, I'm not so sure about it. If this were ground up in a powder and were put into something I was eating, I'd probably feel very different about it. But the legs, oh. Look at the legs, look. The legs. I'm just not so sure about that. There's nothing else in the bag. Let's read what the label says. So we have a zebra tarantula, cooked and dehydrated with a light dusting of salt. It's got no artificial colors, flavorings, or preservatives. It is oven dried. The ingredients: Thai zebra tarantula. There's the Latin name. It has salt. Tarantula is fragile. Handle with care. To maintain freshness, bag also contains 1 oxygen absorber. Best before 12 September 2022. Warning, some people may the fine hairs covering the tarantula body irritating. I think they meant to say some people may find the fine hairs covering the tarantula body irritating. These can easily be removed by holding over a gas flame for a few seconds. Anyhow, there are those little fine hairs. It's funny they call it a zebra tarantula. I don't really see the stripes. You would think there would be stripes. But I am pretty sure this would be totally safe to eat. It's just not really something that I would like to eat. As I said, you grind this up into a powder, put that into food, like say crickets or grasshoppers or spiders, I'd probably be totally fine with it. Probably won't affect the taste, probably a really good source of protein, maybe even a protein shake with ground up insects I could do. And I really must apologize to anyone in the world who does regularly eat insects or arachnids, things like that. I'm not trying to be insulting. I'm just not used to it, and therefore it would be very difficult for me. So I think I'm gonna package this back up, and I'm gonna see if any of my friends would be interested in trying this, because maybe some of them are a lot more daring than I am. All right, we'll move the 8-legged friend off to the side. Let's take a look at what is in this package here. What is this exactly? Well, I'm recognizing this immediately. So it says MFM Rev C, pdp8online.com/MFM. And this here, these are connectors to connect to an MFM hard drive controller. And these would be for connecting ribbon cables directly, I guess. And on the back here, it's got the BeagleBoard Black single board computer. So it's got a micro SD card slot there, Ethernet, USB, it's got DC input, also another USB there. And it is connected to the board through its headers. And that obviously allows for the BeagleBoard to emulate an MFM hard drive. So when he's talking about purity, that means that I can use that original IBM controller and get rid of the IDE one I have in there, potentially alleviating the need for the modified BIOS entirely. I was actually completely unaware that something like this existed. I've seen an MFM hard drive emulator that it was designed for like embedded computers. I don't think it was this one. It didn't use a BeagleBoard, and it was really, really expensive. So I kind of ruled that out as something that would ever be reasonable and worth getting, because why? I mean, it's so expensive. So I am really quite amazed about this. I guess I'm gonna need to go check out their website, see what kind of software I can load on here, and then how this thing works. This is pdp8online.com. I didn't go to the /MFM yet. It's a website all about running the PDP-8. The PDP-8 is a big computer, mini computer actually. It's not a mainframe, it's a mini computer from DEC, Digital Electronics Corporation. And it seems like this website is a really good resource for the PDP-8. But I guess the PDP-8 used an MFM hard drive, at least in one of its iterations, and that's what this board's all about. This is a hard drive reader and emulator, so it's not just an emulator, but it actually can read them. The unit is intended to read MFM drives for archiving and to emulate 1 or 2 MFM drives to replace failing MFM drives. The image read from a real hard drive can be used for emulation. That is pretty cool if you don't have the original disk media to restore a system back to its original configuration. In theory, the unit can emulate any MFM hard drive. In practice, there are enough variations in how controllers use drives that software changes have been made to make it work with some systems. And I have found that myself. I have found that I take like an MFM hard drive out of a PC that's used with one controller, like say on an XT, and I put it in my 286 or a newer machine that has a 16-bit controller from Western Digital, and it doesn't seem to be able to read the drive at all. I have to re-low level it entirely to get the drive working, but it was working for the most part in the original machine. Like, it would boot up and I would see data and files, but yet in the 286 it couldn't read it. So clearly there's a little bit of a difference in the way that the controllers were writing to the disks, because unlike an IDE drive, an MFM hard drive, it's really just a dumb drive mechanism, and the controller is controlling the low-level functionality of the disk itself. You'll need to use command line to operate the unit for reading disks and to configure it for emulating disks. So that would be accessing the Linux that would be running potentially on this BeagleBone. You would SSH into it and you could control it for setting up your disk emulation, and also for potentially, hooking up your hard drive. And I guess that's what these connectors are for here. You would plug ribbon cables into a real hard drive, and then the BeagleBone would then read those disks. That is just super cool. It should be able to read and save the raw transition data from any hard drive using the ST-506 or the 412 interface. He goes on to say that people are still running across formats it can't decode to sector data. For formats that are minor variations, adding support doesn't take long. For some controllers which did their own undocumented thing, it can be a significant effort to figure out the format. Writing to real disks is experimentally supported. Interesting. So the creator has this page which lists various systems that use ST-506 type drives and how it works with this particular emulator here. And you can see like the S100 based computers running the OMT5400 controller, emulation working, but reading not reported. I don't know what that means exactly. There it is, DOS PCs using the Western Digital 1003 controllers. It says reading working. It does not report that emulation does work though. I think that's the intent that Stuart had, that I would use this for drive emulation on the 5170, so I wouldn't need to use that IDE interface any longer. This list is rather lengthy though. North Star Advantage, TRS-80 Model 4P, Deck Rainbow, the Xerox 6085 Daybreak, Xerox 1108. Oh look, the AT&T 7300 and 3B1. So I have one of those that was sent in by a viewer, and that did need a working MFM hard drive, which of course is not working on that machine. I luckily have some working drives, and I'm going to be getting back to that thing. Working for emulation and reading disk. The operating system reserves one spare sector on each track for bad block handling. This machine uses TTL drivers which interfere with the automatic shutdown and power on function. See this page for more information. So that's right, when you look at the emulator board, this bank of capacitors here, I was reading on the other web page, it says that this allows for this board to be powered directly inside the computer from the regular power connector here, the Molex. And what happens is when you cut the power on your main computer, the capacitor bank here allows the BeagleBone to correctly shut down Linux and everything, and doesn't just kill power to it. So it's graceful shutdown. Yes, okay, so if it's using TTL drivers instead of open collectors, it prevents the shutdown from happening. Looks like he just removed a couple resistor networks off this board, and he said he verified it works fine in R7300 without the resistors installed, and that allows this board to have the graceful shutdown. And just scrolling through the rest of this, I mean, tons of machines are supported. Kaypro, Televideo, TRS-80 Model 16, Tandy 6000, Model 2, CompuPro 8-16, industrial equipment, some Russian clone machines, Wang. I mean, this is awesome. TI-99 4A, ST-225, that was the original Seagate drive that would have had in it. PDP 11/23, that's with a ST-506 type drive, emulation working, and so is reading. Atari ST with the Atari SH-205 Megafile, had some kind of Tandon 265, and that's like a 20 meg hard drive, it's a 3.5 inch, working for reading. Commodore 900, that must have been some type of hard drive, maybe for the PET or something like that. IBM RT 6150. And here is pricing. Production bare board, $15. See this page for ordering BOM from Mouser or DigiKey. My so-so hand soldering of surface mount chips, $5 plus $3.50 a chip. Assembled board with the BeagleBone Green, BBG, and the PCB, $175. Whoa. Or $125 without the Beagle board. And it does say the BeagleBone Green is a cost-reduced BeagleBone Black, and that should work fine. But this one here, I can see there's a sticker right there. This is a BeagleBone Black. And shipping within the US is $4 for USPS, so that's not too bad. You can get the board shipped to you in the US for $19 US, or it's quite a bit more to ship to Europe. I clicked on the link for the bomb on DigiKey and it doesn't seem to work properly. The Mauser bomb works fine, and it's the BeagleBone Black, or the green, I'm sorry, is $50. That's the most expensive part here. Everything else is relatively inexpensive. I mean, supercapacitors, that's for the shutdown here. These are 10 farad caps here, so those are somewhat pricey. You could buy more inexpensive ones from Asia, from China, things like that. So $116 on Mauser for the bomb. 50 of that, of course, is a BeagleBone, and like I said, $14 for the super caps. Still about $50 worth of parts. You could definitely do it more inexpensively if you already had some of this stuff, or you bought stuff from China. There is lots of great information here on assembly, and he talks about the super caps, so 10 farad caps are recommended. They'll give you a 50-second runtime, which is plenty of time for shutting down using a reasonable size write buffer. And if you are thinking of making one of these yourself, it's really just these two ICs here that are the surface mount components. Everything else is through-hole, at least I think everything else is through-hole. There's nothing under the BeagleBone here. The schematics are here. This is obviously designed in KiCad. I call it KiCad. I don't know if it's KiCad or KiCad, but I call it KiCad. And this section here talks about how to mount this in the machine. So use 2 blocks of wood to screw it onto the PCB, and then you can attach the drive rails. Hey, you know what? That works. Or there is a 3D printed mount as well. It says here the BeagleBone Black actually is pre-configured to go right into the OS. It doesn't, I guess it has built-in flash memory. You don't have to use an SD card like a Raspberry Pi. So since this seems to be a pre-built board, you can skip this step. But he does have all the information about loading the Linux version, I guess, you need onto the BeagleBone if you're doing it yourself. Okay, well, I think I've done enough looking at the website. Now I'm gonna try to digest some of that information and figure out how to get this thing up and running so I can do some rudimentary tests with it. All right, for proper testing of the MFM emulator here, I have an actual MFM hard drive. It's an ST-225. I have a 16-bit MFM hard drive controller and a 386SX motherboard for testing. So first thing to do is plug in this controller into this board. I have the little monitor here hooked up for VGA. Let's power this up. This hard drive should have DOS already on here. It should boot. I think there's some files on here. So it'll be perfect to hook up to the emulator and try to copy what's on the drive onto this first, and then try to emulate this hard drive with this controller and see if that works. So it does appear to be booting. And sure enough, it's got Check It on here, plus a bunch of other utilities. So yes, it's gonna work perfectly for this testing. So I shut this down. It's a bit noisy, so sorry about the noise. As I had mentioned before, you do need to connect it to the BeagleBone using Ethernet or Wi-Fi. The website talks about a couple different methods. You can plug in a USB to serial adapter and get a console that way. I'm gonna try using Ethernet. And before powering it up, there is a jumper here that says drain and fill. Well, on the drain setting, it will drain the supercapacitors, and on the fill setting is it will route the 12 volts that you plug into here into the supercapacitors. It's probably not something you want to do testing, just so you don't have 12 volts floating around in here when you think this thing is turned off. It's actually still running for up to a minute from the supercapacitors. So I'm going to leave this on drain, and I'm going to connect up one of these power connectors, and I'm just going to place the board here. I'm not going to connect the drive up yet. I'm just going to connect the Ethernet cable. I've unplugged the power cord from the hard drive just to eliminate the noise, and let's power this on. Okay. I don't see any activity, but that's normal. Oh, there are some LEDs down here showing up on the BeagleBone. That's pretty cool. The default configuration of the BeagleBone is to use DHCP when you plug an Ethernet cable in. And I'm logged into my router, which is my DHCP server, and I can see the IP address of the BeagleBone. Okay, here is PuTTY. The documentation said use root, and there was no password, and there we are. Whoops, we are logged in. Last login was August the 6th. I guess that's when this thing was tested. Today is the 14th of August, so this thing was recently accessed from that IP address. So I have to keep in mind that this is being powered from this power supply that the 3D6 is hooked up to here. So if I just turn this off, the BeagleBone will just do a cold shutdown without properly saving and synchronizing the files. So I need to do a halt before I just turn the power off on this. And that's, of course, until you get the capacitors charged up, and then there is a script that detects that the power has been removed, the main power, and it will initiate the shutdown, and it will complete in the amount of time that the supercapacitors can still power this board up. It mentions it in the documentation that you do not want to power the BeagleBone from this DC jack here while this is connected to the board. You also don't want to power it from USB. While it's connected to the MFM board, you got to power it from this connector. Now I know the BeagleBone is actually working. I'm going to shut this down with Alt-P, and I'm going to connect the hard drive to the connectors on here and then power this all back up so I can try reading this hard drive into the emulator. Alt-P. I am pinging the BeagleBone right now and I can't reach it, so I'll just let it sit for a little while. I see the hard drive, I see the LEDs are sort of blinking here. I'll wait till there's no more activity. Oh, it came right back up. Well, what's the correct way to shut this thing down then? I did read that he said that when you power it off, it does power itself back on again, and that's when it detects that this thing is still powered up. And it does that because if you want to turn the power off on your computer, it will shut down the BeagleBone, but then say you turn it back on after like 3 seconds, then the BeagleBone needs to shut down and then come back up, otherwise you'll have no hard drive emulation. So that's a little interesting feature. So I don't really know how I'm supposed to properly shut this down while the capacitors are not charged. I'm looking to see how you actually power off the board. And it says it does, it powers down and comes right back on. If you really want to power off the board, you need to remove 12 volt either before or during the power off. I use Alt-F and remove the 12 volt when I'm shutting down the board. This halts but doesn't power off the board. Okay, so yeah, the -F prevents it from running the shutdown script, which is what makes it come back up. So I am logged back in again, Alt-F instead of Alt-P. And I guess it should, oh yeah, okay, no more LED activity on here. So I guess it's off. So I'm gonna turn that off and let's connect up the hard drive to this thing. I have the hard drive connected. There's a jumper here that allows you to enable and disable writing to the hard drive. And I guess he warns you to take that off just so while you're running the scripts on here, you don't accidentally erase your hard drive. Of course, in my case, I don't care because this has nothing unique on it. But if you're working with a hard drive from a system that's super rare and you're trying to preserve the data, you clearly don't want to accidentally write to this. We have a 34-pin connector here, so that's a given where that goes, but there are 3 that look like the small ribbon cable can connect up to. But on the website, it says for reading, you attach to J3 and J4, and there are silkscreen markings here, J4 and J3. There is one other thing to note, that this 34-pin cable here that goes to the hard drive seems like a floppy cable, but it's different, and it has to do with that twist that is in the cable. If you are missing the correct MFM cable, you can convert a floppy drive cable to work, but you will need to worry about that flip that's in the cable. So just keep that in mind. And I think if you Google, you'll find some information on how to fix that. All right, back on the website, ensure the cables are attached to the proper orientation. Data can be erased if they're plugged in backwards. Well, these are keyed, so nothing can go in the wrong way with this cable set. But you could have, say you built the board up yourself, you might not have put the shroud around the pin headers on here, then you could easily plug it in backwards. It says verify the drive has terminating resistor installed. I know this drive does. This is the terminating resistor on the ST-225, but it's obviously going to vary depending on which hard drive you're using. Okay, I think I'm ready for power up. Here we go. BeagleBone LEDs are blinky blinky. Let's restart our session on PuTTY here. Root. Boots up very quickly. And it looks like these are the commands that we're going to run. First we run this setup command, so let's just do that. RevC board, okay, that was pretty quick and easy. Okay, so there's an analyze command that seems to maybe analyze what's in a file compared to what's on the drive, but we can also just read the entire file. It outputs it to emu_file_a, and then we have the heads and the cylinders. No, what analyze does is it tries to analyze what your drive is. So I don't know, let's try this. There's a lot of nuance to this because there's also some transitions file. which it contains more information. It looks like for later analysis. It's almost like reading the flux off a floppy drive. I guess I don't really understand here. EMU file A, is that like the output file? And then you're supposed to put your own file name in here. And I'm going to change file name from just generic file name to DOS621-ST225, which is what this drive is, and we'll see what happens. Okay, RPM, 3,599.4 RPM, which is correct. And the hard drive LED on the front of the drive is blinking, so it's doing something. Now what's cool is because this write jumper is not installed. Oh wait, here we go. Polynomial 1021, length 16, initial value FFFF, sector length 512, data CRC, polynomial, blah, blah, blah. Selected head 4, found 0. Last good head is 3, and that's correct. This drive is pretty standard. It's like a Type 2 drive. I wrote Type 2 on here. It's got 4 heads, 17 sectors per track, something like 620 cylinders, I think. Or sorry, it's 615 cylinders. So there we go. It says 21.4 megabytes, which is totally correct. It is finding some bad blocks. Now, I did run SpinWrite on this drive, so it completely has some bad blocks actually mapped out, and there is a text file at the root of the directory which does say what exactly was bad on here. So I could check that out. It's probably got a handful of bad blocks. In fact, I suppose it's understanding that from when SpinWrite ran, it actually did put that in there. But here it is, look at this. The format, WD1006, which I think matches this controller that's here versus the 1003 chips that are in use on some of them. 17 sectors per track, 4 heads, 615 cylinders. This is totally working. 512 sector length. Cool. Now this is reading pretty quickly here. It's at 380 already, 390. Like I said, I ran SpinWrite on this drive. I run SpinWrite on all of my MFM hard drives, and I let it do the very extreme testing, which takes overnight basically to run. And I let it just check every sector on the drive over and over and over again. So if any of them are marginal, it marks them as bad. And this drive, as I mentioned, it's got some bad sectors on it, but it works absolutely perfect. It just found another one here as it's scanning. Now the error map that's actually stuck on a sticker here has nothing written there, but this drive is very old. It probably was from, 1984, 85, 86 kind of thing. It's developed some bad sectors, but all things considered, this thing works really well. All right, so it expected 41820 sectors, but it got 41814 good sectors. So like we mentioned here, there were 6 bad sectors, totally fine. And it says that 6 sectors were marked bad or spare, which was SpinWrite's doing. As it reload levels the drive, it does mark those in a way that this thing can understand that they are bad. And luckily, DOS was not trying to use those bad sectors. So no data is actually lost on this. And again, that's all because I used SpinWrite. So there is a very specific command line that this created after doing the analysis to allow you just to read this drive easily again. I'm very curious about the WD1006 versus WD1003. And as I had mentioned, this controller here, this 16-bit Western Digital controller, wasn't able to read this hard drive, even though I took this out of a working machine and it had data on it that was visible to the original controller. This couldn't see it. So then I just re-low-leveled the hard drive from scratch, just to completely start fresh, and then I could run that SpinWrite process, which took overnight to find those bad sectors. All right, so if we do an LS here, did it create the file that I thought it would? What was the name of the file I created? DOS622-ST225, there it is. So let's look at that file, and we should have 20 megabytes or so, and there it is. Very cool. All right, so further down, we want to do the emulation now. So you start the emulation, which doesn't start by default on this board at power up, but you can configure it to do that. That way, it will automatically start up when you have it inside of a machine. I was about to do Alt-F to shut this thing down. It'd be kind of cool if there was a park command in here, like MFM_park, but I guess that doesn't seem to be the case. All right, let's shut that down. The LEDs have stopped going on the BeagleBone, so we'll turn this off. And now I can take this hard drive and let's move it off to the side. I need to be careful with it until I park the heads. and we're going to flip around these cables. So the cables plug into the Winchester connector there, and we're going to plug this back in here. This is all very nicely keyed, so I can't plug anything in the wrong way. Now this does support 2 hard drives at the same time. Now I'm only going to try emulating one, but to do the second one, I have a feeling I would plug it into this connector, and that would go to the second connector that's on this card here. It says drive 1 and drive 0. I'm on the drive 0 connector, which is the main one. Yeah, it's got to be that. I still don't quite know what this is for, but we're just going to try this like so first. May as well test out the supercapacitor, so I'm going to move this jumper over to the fill position. Everything is connected and ready to go. This will put some more drain on the power supply while it fills this. There's a large power resistor right here. I have a feeling that's like an inrush current resistor to prevent your power supply from having an issue. I saw something on the website where it said that if the computer doesn't turn on, like it's pulling too much current on the initial power up, you need to put a larger value resistor there, which will more slowly charge up these capacitors. With this set to fill, this red LED should come on when these are charged up, just to give an indicator that this board is still powered up, even though I may have turned off the power to the entire computer. Here we go. Okay, there we go. The LED did come on. It is lit, and the BeagleBone is blinky blinky. Now the computer is trying to access the hard drive, and it's going to fail, and that's because the emulation is not starting by default. Okay, so on here it's reporting drive C failure, which is completely understandable. Okay, so what we're going to do is we're going to go to the EMU directory as it says, and we're going to do setup EMU, rev C board, and then we do MFM EMU -- drive 1, and then -- file, and now the directory that it's in is back one, MFM, and it was called this file right there. I think that should do the trick. Okay, that didn't work, and actually I guess I realized that I need to point to this EMU file A, which I did run in that command, that previous command. Like this file here actually has the raw sector data, but that EMU file A right here, EMU file A, that must contain basically like the heads and cylinders and all the other information about emulating this hard drive. So I'm just going to point to that and hit enter. And there we go. Guess it's working. So on the computer here, I'm just going to hit Control Delete. We should see, okay, it works. It freaking works. Look at that. Look at that. How cool is that? So really my question is how fast is this? So I have Check It on here, and I didn't show this, but I ran Check It before on the original hard drive, and with this controller and that actual hard drive, it's a 1-to-1 interleave, I was getting about 330K per second on this benchmark right here for the hard drive. So I assume it's going to be identical. It's probably going to be exactly the same. 300K per second. It's exactly the same, exactly. Now the seek times should be a lot faster, and they are. So the seek times, which are these two graphs here, this is compared to an XT machine, were about the same. Like it was roughly as big as the bars here for the XT. It was the transfer speed that was quite a bit faster, 3.53 times the XT. That's exactly the same. But the seek time is a lot quicker because, of course, this is emulation. There's not an actual head that's moving. So it is faster, but it's not like instantaneous. And that's because through these cables, it's sending signals like step to the next track, step to the next track, things like that. So that's why it's not instant. Pretty cool that it just worked. Why don't we run scan disk, and I'm just gonna do like a full surface scan of the entire drive, and we'll just see how quickly that goes. So here we go, surface scan, and there it goes. And these are the bad sectors that were mapped out before using SpinRite. Anyhow, it's going pretty quick here, and as it runs, we can see stuff moving up on the screen. But that is totally working. How cool. And take a look at that. It worked. It fully verified that hard drive, the emulated one, and it freaking works perfectly. What if I type park on there, just park the heads? Okay, next test is take this controller out and put in the original IBM one from the 5170 that basically was causing me so many issues. I'm just gonna set the jumpers here, so this should be the primary configuration. All right, everything's connected. Let's turn this back on. I'm always amazed that that board still doesn't have more shorts, so it actually works. And here we go. BeagleBone is flashy, and I'm getting my pings. I'm not doing a screen capture, but I'm just running the same commands I ran last time. Hit enter, and I'm gonna reset the PC here. It just had a hard drive error, as it should. Is this gonna work? No, it says write and step are active. Is J2 cable reversed? It's definitely not reversed. Pin 1 is up on this board. The stripe is right there. And on here, J2, which is the larger cable, the stripe is right here. Maybe, I think, okay, so see this cable is straight through, it has no twist at all. I think this controller expects a cable with a twist. I'm gonna shut this all down and go grab the right cable. This is the original harness from the IBM 5170, and this connector here says C on it, and notice there is a twist in there. And this one says D, and it does not have a twist. So that's different than this controller. It obviously was working perfectly without the twist, and the cables that were on here, the ones I'm using right here, were already plugged into this. So I guess there's that little bit of difference there. I just did a Alt-F on here. Let me just wait for the pings to stop, and I'll kill the power. There we are. And let's connect this up like that. Nice click. It's kind of a tight fit. It's all gonna have to hang here because I don't, because the cable's too short with all this tape on here. It says select 1, head 3. Let's reboot the computer. Now I don't actually know if this IBM controller works. So it may be faulty. In fact, it's not really working right now. It actually just says hard drive controller failure right here. I'm gonna power this off. Whoops, I just powered off the BeagleBone. How rude of me. I'm switching the jumpers around to the other setting on this board right here, and that selects if this is a primary or secondary controller. Okay, and I just started it up again. Unfortunately, it's still saying hard drive controller failure right there. This card just might be bad. I wonder if that has a lot to do. Oh, and it just caused a core dump on the emulator process. What I never actually did is test this with a real hard drive. It's quite possible this card is bad. Now I actually have a second one of these cards, so I'm gonna have to dig that out and we'll have to test that and see if there's any difference here. And here's the spare. This was in that box of mystery PC parts, the one where I got that 5170 motherboard from that I overclocked. I haven't tested this, so this may have shorted tantalums, who knows. I think it was one of these that was shorted on the other board, if I recall. So let's pop this one in. This one looks a bit older, by the way. It's got this ceramic package. This is ceramic here, but it is the same card as this. They're both the same. I'm noticing that this older card has a bodge there. There's a bodge there. There's a big dent in that crystal oscillator. Back of the board is bodgeless though. I have the emulator disconnected. Before I plug anything into this thing, let's just turn this on and make sure the board at least lets the computer power up, like it doesn't short the whole power supply. Here we go. Okay, it's running. Let's see what it says about hard drive error or controller failure. It could be totally normal that when this is not seeing a hard drive that it likes, that it just shows a controller error message. That might be normal behavior. All right, everyone, check it out. It says drive C failure. That matches the newer Western Digital card, this one. So I guess this card might have just been faulty the whole time. That's, oh, what if that was causing so many of my errors, my 601 errors and all that stuff. All right, plug these cables back in. I know this all looks very precarious, but it should be fine. Nothing is touching. Ethernet cable is in, power's in, cables are good to go. Okay, here we go. Okay, I'm logged in. Let's start up the emulation. Set up emu, mfm _ emu -- drive 1 -- file / and then back in the previous directory, emu file A. And here we go. Select 2, head 0. I don't know. Let's reboot this. It said drive C failure there, but it had already pretty much timed out entirely. All right, doesn't seem to be working. The other one just sort of came to life immediately. I wonder what's going on. Let's switch back to the other cable, the one that doesn't have the twist in it. I keep accidentally powering this thing off without properly shutting this thing down. I feel bad. It's bad for it. I mean, I haven't written anything to the drive. Probably the most likely thing to happen is it could corrupt the drive image. But since I'm not really writing to the drive, it's not that big a deal. Okay, here we go. We are started. Hey, it's working. Look at that. It's working. All right. So cool. So things are working really well with this IBM card. Now I have gone ahead and enabled the supercapacitor, so the red LED is lit. The system is currently booted, and I am SSH'd into the system right now. So I've gone ahead and I've enabled the emulation to start at power on. And you just run this system control command here to turn the service on. And he says it takes about 12 seconds from power up for the system to be ready to emulate the hard drive. You can also disable it with this command. So I'm gonna kill the power on this power supply and let's see if this thing shuts down properly and then comes back and is able to boot this machine automatically. So power it off. And I can see the LEDs are blinking, and on the SSH session it says power down. Now even though it is shut down, the beagle bone is actually powered up right now, which hence the red LED is still brightly lit there. So I'm gonna turn the power back on. And let's see if this thing kind of comes back to life. Look at that. Beagle bone is booting back up again. And on the machine here, it says wait. I think it's trying to communicate to the hard drive. And that's it. Look at that. It's starting to boot. Now, this disk controller obviously knows that spinning hard drives take time to spin up. So it probably has some amount of tolerance designed to sit there and wait for the hard drive to kind of become ready. Now, you might be noticing that it seems to be booting relatively slowly. And I think that is a problem right now that's happening with this card. It has nothing to do with the emulator. Let's go into check it here. Check it is actually taking quite a long time to run, but it does work. So we'll go to benchmark and hard drive. Let's see what we get here. Yeah, 30K per second. Remember we were getting 300K per second with the other card? I think the problem is the way I had this hard drive formatted. I had set it up for a 1-to-1 interleave because that gave the best performance with this card. But I have a feeling that the IBM card does not like a 1-to-1 interleave. It probably will work better with a 2-to-1 interleave. And the problem is if you are one step too fast, like the interleave is one step beyond, the performance is like 1/10 the speed. And I have a feeling that's what's happening. Let me plug a floppy drive into this thing and we'll boot up into SpinRite, and that will give us some benchmarks to see which interleave is the best. I apologize for recording the screen here. I just don't have the video capture stuff set up right now. So let's do this check here and just see if the emulator can trick this thing into thinking that there's a real hard drive connected to this controller. I mean, it's doing it. Track to track is 0.50, full stroke 22 milliseconds, and then the random seek is going rather fast. It's so strange to see this running without hearing the hard drive doing its seeking. 3599.16, which I think was exactly what this hard drive I imaged was running at, because when I backed up the hard drive, it actually showed that as its drive RPM. So the emulator actually emulates the speed of the drive so precisely. That is incredible. I'm more and more impressed by this thing by the minute, honestly. This thing is very impressive the way it works. Okay, so it's finished the analysis, and certainly current sector interleave is 1, so 1-to-1. Revs to transfer one track, 17. That's part of the problem. Okay, here comes the analysis to show what will be the optimum interleave. And I'm gonna guess it's gonna be 2-to-1. So there it is, throughput 30K. Look at that, yep, 2-to-1, 261K per second. Definitely not as fast as the 1-to-1 that was possible with this card. The timing in this card, I guess, is just a little bit tighter, and it allows that 1-to-1 interleave to work so well. But on the IBM card, 2-to-1 is gonna be appropriate. But I want to reiterate the fact that the need to change the interleave on the emulated drive has nothing to do with the emulator, because this hard drive would have exactly the same problem. It's all down to this controller card. I'm also going to add it's quite possible that this card on the original 5150 running at say 6 or 8 megahertz also may not work properly at 1:1. It might be too slow as well. It worked fine in this 386 running at 40 megahertz, that 386SX that is. There are a lot of factors that determine what the optimum interleave is, but it's never the drive itself. It's always the controller or the computer or the ISA bus, stuff like that. I exit out a spin right and it says, please remember to park your drive heads. Yeah, right. So Color Me really impressed with this particular project. I was a little unsure because the website and everything just didn't look super slick, but the fact is, this thing works incredibly well, at least in the context of PC emulation, which is obviously all I've tried so far. It's a little bit expensive for a fully assembled board, as seen here, but if you really need to use an MFM hard drive on a weird, obscure system, like say the AT&T Unix system, where you can't just pop in replacement IDE controller card, XT IDE, things like that, something like this is really a lifesaver. And the fact is, the creator sells the PCB, which is a really nice high quality one with gold on the contacts here, for under $20 shipped, which is pretty reasonable. The rest of these parts on here, especially if you don't install the supercapacitors, are very inexpensive. I'm super blown away that I took an actual MFM hard drive and I imaged it into the emulator and that it perfectly replicates that original hard drive, bad sectors and all, exact RPM, everything about it, and that's what it presents to the MFM controller. So now what's left for me to decide is if I'm going to put this in the IBM 5170 to restore a little purity. It would just allow me to use that original MFM controller card and take out the IDE card, or save this for use in the AT&T Unix workstation, which was going to require me to reinstall an MFM hard drive in there, an actual MFM drive, which I assume is just going to fail anyways, and they're so noisy. Personally, I really don't like the noise of hard drives, the old hard drive sound. When they switched to fluid bearings on hard drives, somewhere in the multi-gigabyte IDE drives, I was so happy. I just love how quiet those motors are versus all these older drives. Just such loud whine. It's always like a big detriment of using a hard drive. A necessary evil, but a detriment. And something obviously with solid state drives, we don't even have to deal with the head seeking noise anymore, which on modern drives is really quiet, but you can hear it. Anyhow, so thanks again, Stuart, for sending this in. Really cool project. There will be links in the description, of course, to the website so you can buy your own and all that information that I've shown on the captures. And thanks to all my patrons. Their names are scrolling up the side of the screen. I really appreciate your support. Comments down below, thumbs up, thumbs down, all that regular YouTube stuff. Check out my second channel. Oh, and about the spider. Maybe if my second channel hits 100,000 subs, I'll eat that on video? I don't know. I mean, people can put comments down below about what you think I should do about the tarantula. Anyhow, thanks for watching. So stay healthy, stay safe, and I'll see you next time. Bye-bye.